Okay, here are your directions for writing quadratic equations from data. The first situation, part 1, write the equation for this parabola and note that the first point is a y-intercept. So what happens is when you have f of x equals ax squared plus bx plus c, the c term is your y-intercept. So we can rewrite this function as ax squared plus bx minus 5. And of course, using the last 2 points, 2, -3, and 4, 15, we should be able to solve this out, getting 2 equations and 2 unknowns. So I'm substituting x's and y's here. As we do that in the first case, we substitute in, and we end up with this. Moving down from here, we see at the end, solve both equations as far as we can, and then do a 2 equation, 2 unknown substitution. We've got on the left side b equal 1 minus 2a, substitute that in for b on the right, solve it out, and we end up with a equals 2. Back substitute that into the other side, and you end up with b equaling -3. Substitute that back into the function, and you're done. You got your first function. So you should be able to do numbers 1, 2, and 3 from part 1. Then come back to this video, and we'll do part 2. Here's part 2. Write the equation of the parabola that contains these points. Notice that the first point here is an x-intercept. So the neat part about that is our function starts out a little different. Notice that the factor x plus 1 can be used because -1 is a root or a 0 of the function. So we only have an ax plus b. Again, we're going to substitute the 2 points, 1, -2, and 2, 6 in, and then solve those 2 situations out. When you do that, you end up with these 2 items. On the left, I solve for b in terms of a, then substitute it on the right. Solve that out for a, you get 3. Back substitute, you get b equals -4. Plug that back in here, you get 3x minus 4, and then multiply it out. And there is the second situation where the x-intercept is given. You should be able to do numbers 4, 5, and 6 now, and then come back to this video for the third part. In part 3, we're writing the equation of the parabola containing these points, and this time no intercepts are given, but these 2 points, 1, 1, and 7, 1, are directly horizontal to each other. So in that case, we do realize that there's a vertex at 4. Right in between 1 and 7, there should be a vertex. So we know the x value is 4, and therefore in this function, we want a quantity x minus h squared plus k, and we know that the h value is 4. So this is all the information that we need to get started, because once again we have 2 unknowns. This time it's a and k. So we'll plug these numbers in. This time I'm going to use 1, 1, and then I'm going to use the 8, -13. The 8, -13 does need to be used as one of the 2 points that you're practicing with. So working this out, again, we're going to put them in both sides, and then in this case I solve for the k in terms of a, plug it into the right-hand side, solve that out, you get a is -2. Once you get that a equals -2, you back substitute and find the k. K is 19. So our function turns out to be this, -2 quantity x minus 4 squared plus 19. And then we, again, work this thing out, square this guy out, distribute the -2, collect the terms so that you can write it in ax squared plus bx plus c form. This should be able to give you an opportunity to handle numbers 7 and 8. And there you go.